Okay, so welcome back, guys. I hope you guys had a good weekend. We're only gonna have one lesson this week, just because it's a shorter week, and this is gonna be a little bit longer than my regular lessons. So we're gonna go through physical and chemical reactions today, or physical changes in chemical reactions. So the main point of this lesson is to be able to determine if a reaction has actually happened. When something changes, when you have a piece of matter that changes from one thing to something else, it doesn't necessarily mean that a reaction has happened. Sometimes it can just be a physical change. Where it's just kind of changing shape or changing the size of it. But a chemical reaction never happens. So today's lesson is kind of to tell you how you know if a chemical reaction has actually occurred. So we have previously covered atoms and their structure, okay, so the number of electrons, protons, and neutrons in different atoms. Different elements and how their atoms are different. So I asked you to draw, several different atoms from different elements. The effect of changing neutron number, the creation of isotopes. So that should be a little bit something new for this year. When you insert a bunch of neutrons into an atom, it turns it into an isotope. And if you insert enough of them, it'll actually start cracking and releasing radiation. And then valence electron numbers. If you start playing around with the valence electron numbers, you can create ions. And we'll get into ions a little bit more when we get into compounds. And then the last thing that we also went over was the physical and chemical properties of elements. So there's basically going through all the different elements and say taking a piece of metal like steel and saying, well, what are some of the physical properties? Oh, it's solid, it's metal, it's hard, it doesn't bend, it has a really high boiling point. And then some of their chemical properties, like it does react with oxygen, it doesn't react with water, it reacts with an acid. Okay? So today we're going to go through something, before we actually get into that. So whenever you look at matter, you can describe it really two ways. You can describe their physical properties, so again, how they look in using our senses, and then their chemical properties of how they react to things. And when we do our worksheet today, I'm going to kind of recap this because it's a very, very important idea of the physical and chemical properties of matter. Okay, so just a quick recap. A physical property is a characteristic or a description of a substance that may help identify it. These characteristics are observed using only our senses. So that's like you looking at it, describing how it looks, you touching it, describing how it feels, you smelling it. We usually don't taste things in chemistry, so you can usually leave the taste out, but it's really just using your senses as the physical properties. And then chemical properties describe the behavior of a substance as it becomes a new substance. Okay, so this is when a chemical property is when you're going to take your substance and then start adding it to other things. I'm going to add it to an acid and see what happens. I'm going to add it to water and see what happens. I'm going to add it to oxygen and see what happens. So the two chemical properties that are often included are, does it react with fire? Okay, is it combustible? And does it react with an acid? If you pour an acid on it, what happens to it? Okay, and today we're going to go through, when we say does it react, we'll be able to explain to you how you know whether it's reacting or not. So just in general, physical properties are how it behaves on its own. What color is it? Does it smell? What temperature is it boil at? What does it freeze at? So boiling point and freezing points are also major parts of physical properties. And then chemical properties would how it behaves with others. Can you light it on fire? Does it react with an acid? Does it react with a metal? Okay, so now what we're going to go through today is the physical and chemical changes. Now, oftentimes, physical and chemical properties get mixed up with physical and chemical changes, but they're very different. Okay, chemical and physical properties are just describing how that element is. Physical and chemical changes are describing if a reaction has happened or it hasn't happened. Okay, so just before we get into it, when we say a physical change, okay, this means that there's no reaction that has happened. Okay? Physical changes, matter just changes, but not the chemical identity. You're not changing the molecules. And then a chemical change is when you actually change the molecules. You make something new. And I'll explain that a little bit better coming up. Okay, so matter changing. So again, matter is just everything that you can imagine except for energy. So it's like it's a basketball, it's a desk. So when matter changes, like ice to water or wood to ashes, it does not necessarily mean that a reaction has occurred. Okay? So when something does change, it doesn't always mean that a reaction has occurred. When matter changes, we can identify the change as a physical change. So a physical change means that there's no reaction has actually happened. Okay? So something has changed, but it wasn't a reaction. It was simply a change of state. So it changed from solid liquid to gas. It changed its size. So if I take a piece of fabric and I rip it in half, okay, it has changed, but it's a physical change. It just changed its size. Or its shape. If I take a piece of paper and cut out, say, a circle, nothing is new has been made. I've just changed the shape of the paper. okay? And this is the key thing right here for physical change, that the atoms and molecules remain unchanged. Okay, and I'm just going to jump ahead just for a second to kind of go through some physical. So now let's go back to chemical changes. So what are chemical changes? Well, a chemical change means that a reaction has occurred. Okay, that's what a reaction is a chemical change. Physical change is not a reaction, but a chemical change is. So if you have a reaction, what that means is that the atoms or molecules have rearranged themselves and created a new piece of matter. Okay? It means that all of the atoms have broken apart and then reformed, and now you have something new that you didn't have before. In a physical change, you don't have anything new, but in a chemical change, you change. You'll see how we're going to help you out because it is a little bit tricky. But before we move on, we just want to finish up that a chemist must be able to identify if a reaction, a chemical change, has occurred, or if the change was simply physical and you didn't have a reaction. As a chemist, it's very important to be able to know whether a reaction is changes. So things like crushing a can. Okay? When you crush a can, the matter has changed, but the molecules in that can haven't changed. They're just rearranged or a little bit different. Melting an ice cube. Okay, you're just changing state. Boiling water, you're just changing state. Mixing sand with water. Okay, you're just pouring water and sand together. You haven't made anything new. You still have the water molecules and you still have the sand molecules. Breaking glass. Okay, you haven't made anything new. You just basically broke the molecules apart. Okay, sublimation of dry ice. Sublimation just means going from a solid to a gas without going to a liquid. Mixing green and red marbles. Okay, there's still the green and there's still the red. There, you haven't made anything new. Chopping wood, you just cut it in half. Shredding paper, again, you're just breaking it apart. Now, this is the tricky one right here. This is the one that always gets people. Dissolving sugar in water. That's a physical change. Now, we're going to talk about why that's a physical change a little bit later on, but it's just something you're going to have to keep in mind that whenever you dissolve something, it actually is a physical change. It's not, okay, I'll give you some, identify a examples of it in a chemical change. So, iron rusting, okay? You have something new here when you have the rust. Before, you had just the metal. Okay, and then you had oxygen react with the metal, but now I'm getting something new. I'm getting rust, which I didn't have before. Okay, burning wood. You would have, a log of wood, but you didn't have ashes before. But after you burn it, now you have ashes, so you've created something new. Okay, metabolism. So that's when we eat food. When we eat food, we actually rip apart all the molecules and we create something new. Okay, something that you didn't have before. Cooking an egg. So cooking an egg, you're actually changing the composition of that egg. You're taking the egg and then you're ripping apart all the molecules and reforming them. It's a little bit of a tricky one, cooking an egg, but I'll explain how you know that the molecules reformed. Okay, any kind of baking a cake or any kind of cooking is usually a chemical change. We'll go through electroplating a little bit later. I think we talked about that in grade 9. A rotting of a banana. Okay, so when a banana rots, you're creating something new. You see this new kind of rotting area? You didn't have that before. There wasn't a brown kind of rot area, but that's new. Okay, vinegar and baking soda mixture. So that's a classic acid-base reaction. Fireworks are a reaction in chemical battery. Okay. Now, chemical changes are a little. If we go through. So, just going a little bit more into physical change. So, physical change, no reaction has happened. Simply a change of state, like from gas, liquid to solid, size or shape. Atoms or molecules are unchanged, and it's usually reversible. Don't say it's reversible. It's not always reversible, but it usually is. So an example would be like solid water going into liquid water, going into gas water, okay, or going the reverse way. Excuse me. Since the molecules are exactly the same, it's just a water molecule in the solid, liquid, and gas, and that hasn't changed. It's H2O all the way through. Then we say that that's a physical change. Okay? No new molecules are creating. It was water before, it's water at the end. So as water changes from ice to water vapor, the change is physical. Because it's the same molecule, it's just H2O in ice, water, and vapor, they're just farther apart. That's the only difference. So that's a physical change. Okay, chemical change. So these are the more important ones because it's the reaction. So a chemical change is the reaction. Atoms or molecules have rearranged themselves and created a new piece of matter. Okay, so let's take a look at this. So originally we have CH4 and oxygen. So this is methane or natural gas, CH4. Okay? Now, the fact that we know it's a chemical change is look what's happened to the hydrogens. So I'm going to highlight the hydrogens here in blue. Okay? They've disconnected from this carbon, and then started reforming with hydrogen to make water. So we have something new. We have water over here, and we didn't have water before. So I've created a new molecule. Okay? And whenever you create something brand new, that's a chemical change. Now, if you also look at, say, the oxygen. So the oxygen was in these two molecules, but now I have an oxygen here and there, and I also have an oxygen here and here. So I've created new molecules. I didn't have CO2 before. Okay, I had oxygen and CH4, but now I have two new molecules. I only needed one new molecule, but whenever you create something new, that means you have a chemical change. So a chemical change is one in which there is a change in the starting substance or substances, accompanied by the production of one or more new substances. So these are the new substances, CO2 and water. Okay. Now, most are irreversible. Now, we don't want to keep using that term reversible and irreversible because it's always most and sometimes, so they're not, in fact, laws. But most times, chemical changes are very, very difficult, if not impossible, to reverse. It's hard to take CO2 and water and then go back into methane and oxygen. Okay, so when the matter just changed, when something happens and there's a change, we have to be able to know, well, was that change physical and no reaction actually happened? It was just a physical change. Or did we just actually see a reaction? And now we have something brand new that we didn't have before, okay? Now, that's obviously a more interesting thing when we do a chemical reaction because you're producing something that you didn't have before. So it should be a little bit more interesting than physical where you're just kind of just changing the shape or the size of it. Okay, so did a reaction just happen? How are we going to know? Okay? So it's very important as a chemist to know if a chemical reaction or chemical change has occurred. If a reaction or chemical change did occur, there would be a new arrangement of particles like we have here, CO2 and H2O. And a new substance had to have been made. But how do we know, though? Okay, this is the big question. If we can't actually see the atoms, we're not going to be able to see atoms disconnect and reform. They're way, way too small. So we can't see them rearrange themselves. So how are we going to know that they created something new? Okay, how are we going to know that they broke apart and then rearranged themselves? What we have is we have these things called indicators. So we have 5 telltale signs that a chemical change or a reaction has actually happened. So when you're looking at the change that occurred, you're kind of looking for these signs and saying, okay, I see this, I see this, I see this. This is probably a reaction. Okay? So these are indicators that a reaction has happened. Now, when we say indicators, it's not 100% of reactions happen if you see this. Okay? These indicate that you are probably seeing a reaction, and the more indicators that you see, the stronger evidence you have that a reaction has occurred. So the first indication that a reaction actually has occurred, so the change that you saw was a chemical change, is that you get a change in color. Right? Is the color of the new, you get a new color that you didn't have before. So for instance, say I do the reaction between sodium, which is a metal. So I've got this piece of metal, which you know what metal looks like, shiny, reflective. And then I take chlorine gas. Now chlorine gas is not really purple, but in this case it is. I don't know why I just colored that. Okay. So I've got chlorine gas, which is, we'll say this is purplish green color, plus sodium metal, which is the metallic color. And when they combine together, we get a brand new color. Okay, and I'm just going to put this as red, even though we know salt is not red. Well, if you get a color that you didn't have before, so I had purple and I had, say, the color metal, and now all of a sudden I get this red color, the appearance of a new color means that you probably made something new. Because where did that color come from if you didn't make something new? So that's a good indication that you have a change of color. Okay. The next one is a change in odor. Okay, so it's not just having an odor. Okay, because sometimes this thing, the first reactant will have an odor, or this one will have an odor. But what we're talking about is a change in odor. So say this one smells like alcohol. Okay, so it's got an alcohol smell. This one smells like an acid. So those are our original 2 smells. Okay, so they have odors, but those are the original ones. But then when I combine them together, all of a sudden they don't smell like an acid anymore or alcohol, they smell like roses. Okay, so this is how we make artificial smells. And artificial smells are really just alcohols and acids together. Now, because I got a brand new smell over here, this indicates that I made something new. What's producing that smell? Okay, it's not this acid because it has a particular smell, and it's not alcohol, it has a particular smell. But what has happened is these two have combined together, created something brand new, and that's why I'm smelling something brand new. Okay? So a change in the odor is an indicator that you've created something new. Okay, number 3. Bubbles are visible but not caused by heat. So if I see a bunch of bubbles start popping up, but it's not because I'm boiling water. If I boil water, I'm going to see bubbles, but that's a physical change if I just turn water into water vapor. So it has to be bubbles start appearing, but not caused by the fact that you're heating something up. So an example would be like Mentos and Diet Coke. So if I mix these two together, Mentos and Diet Coke, without having any heat, I'm going to see this huge surplus of bubbles. And this is an indication that a reaction's happening. What's causing this bubbles is that you're creating a gas. Okay, you're creating a gas that you didn't have before. And that is indicated by these bubbles. So we've got a change in color, a change in odor. Bubbles are visible without heat. Okay, more to go. Next one. A new solid is seen. Okay, so this one's a pretty easy one to understand. It's basically if you have two liquids. So if I have liquid 1, okay, and then liquid 2, and then all of a sudden when I mix them together, I get this solid piece right here. Okay, and a solid would mean that all of a sudden it becomes solid or like a jello. Okay, that means that I made something new because this substance 1 is a liquid, substance 2 is a liquid, but when I combine them together, substance 3 over here is a solid. Okay, so the fact that it's solid means that you've probably created something brand new. Okay, because what's making that solid? So that's an indicator. If you see a solid made before that wasn't, that's an indicator that you made something new or a chemical reaction happened. And our last one, and this is kind of related to fires, because whenever you see a fire or something's burning, that's an indicator of a chemical change. Okay, nothing burns that isn't a chemical change. So what if we take a substance, okay, and we combine it with another substance, and then all of a sudden it starts on fire? Okay, it starts burning, or it releases a whole bunch of light, or releases a whole bunch of heat. Any of those things, if temperature or light is given off, that's an indicator that a chemical change has just occurred or a reaction has happened. Okay, and usually that's related to fire. So whenever you see fire, you know that a chemical reaction is happening. Okay, so just to summarize, if a change, okay, so you watch matter change. If a change produces one or more of the indicators, okay, so it has a change in color, it has a change in odor, a solids form or bubbles are formed, okay? It doesn't prove that the change was chemical. It only indicates it. The more indicators that you have, the more confident that you are that the change was in fact a reaction or a chemical change. If you don't see any of the chemical change indicators, the reaction was most likely physical. Okay, so that is it for today, guys.